So in the next three problems, we have a little variety of things going on here. First off, we're asked to determine the range of the function negative 3x squared plus 5. Now we have a quadratic. Now the domain of a quadratic is all reals. The range, however, because a quadratic can open up or down, is going to be from the vertex up or the vertex down. Because we have a negative a value, we know we're going to have a quadratic that opens down. So what we need to do is identify the vertex. Now this one's not too bad because it's centered on the y-axis, so the vertex is 0, 5. But just a reminder, for a quadratic, to find a vertex, x is negative b over 2a. That's the input of the vertex. For in this case, there's no b, so that would be 0 over 2a negative over 2 times negative 3, which is 0. So that's how we're getting the 0 there. And then we'll plug the 0 into our function to get the y value. So plugging 0 in, you get 5. So our vertex is 0, 5. So always identify your vertex in your quadratic, and that'll give you your range, because it's going to be from 5 down. So negative infinity up to 5. And we do want to include 5 because it is one of our possible outputs. So what matches up with that? It's not going to be x less than or equal to 5 because those are the inputs. It's going to be y less than or equal to 5 for the range. So for a quadratic, it's always your vertex up or your vertex down, and it's the y value of your vertex that you use. Finding the zeros of the function, we're going to do this algebraically. So the zeros are when the output is equal to 0, not the input. That's called the y-intercept or the vertical intercept. So we have a few different options we may want to try for this one. Factoring, graphing calculator. So first thing, if we try to factor, well, the only factors of 5 are 1 and 5, but it has to be positive, so they either both have to be positive or negative, so it won't factor. So we can't do that. Well, that means we're not going to have integer zeros, so let's just take a look at this graph and see what's happening. I'm going to put it in as x squared minus 4x plus 5. And I'm going to do a zoom 6 to put it in a standard window. Notice it doesn't hit the x-axis. So what that means is I have no real zeros. If it hit the x-axis, we could go ahead and use the graphing calculator to find those zeros. If you want to see that, I have another video on YouTube that you can go ahead and check out. Alright, last one. Domain of this function, g of x equals rad x minus 4 over x plus 4. Okay, we got two things going on here. The first one is that we have a radical. We can't have a negative in the radical. Second is we can't have a 0 in the denominator. So right off the bat, we know x cannot equal negative 4. Okay? Because if it's negative 4, we get a 0 in the denominator. Now the top, we need whatever's under the square root, the x minus 4, to be greater than or equal to 0 because we need it to be positive. Now we can solve this inequality, and that gives us x has to be greater than or equal to 4 because we need this to be positive. Now, one thing to note about this, negative 4 is less than 4, so this is already included in this domain. So this is really the only thing we need. So we want to look for the one where x has to be greater than or equal to 4. b is close, but 4 is okay. The square root of 0 is just 0. So we want that in our domain. So we want answer C.